Okay, so today what I want to do is go over a few things remaining in the lab that you have to do, just to explain to you how you do these. So first thing I want to go over is this modern day Mendeleev. So what you have here, you have three mystery elements. And this is kind of what Mendeleev did. Mendeleev had a periodic table, but he had some elements that had not been discovered yet. And he looked at the elements that were around it in his periodic table, looked at those properties, and made predictions for the properties of these mystery elements. And that's what you're doing in this activity here. So we have element X. So I want to start with element X just to show you how you could start making some predictions. So let's go back up to our data table. And here we have element X. And I'm going to highlight it. And what I want you to notice is the element X is right between silicon and tin in the group it's in, and it's right between gallium and arsenic in the period it's in. So what I want to do is look at the elements around it. So if you look at silicon, so if we were to predict the radius, remember the radius is in the lower left-hand corner. What we would see is that silicon's radius is 1.17 angstroms and tin's radius is 1.41 angstroms. So we would know that X would have to have a radius between those. But we also have to keep in mind is that it has to also be between gallium and arsenic's radius. So if we think about that, initially, you might think if you just looked at the group that maybe the radius could be like 1.3, because that would be between 1.17 and 1.41. But if we looked at the period also, we would see 1.3 would not fall between 1.25 and 1.21, so that wouldn't work. But if we chose something like 1.23, we would see that would fall with the trend for the group as well as the period. So that would be an acceptable value for the radius. So that is what you're doing in the modern day Mendeleev. So some of these will have very clear trends, some of them will not, but I want you to try to come up with a prediction for these four properties here for each of these three elements, X, Y, and Z. And when you're done, what you're then going to do is you're going to compare the values that you predicted with the actual values and then come up with a deviation. And deviation is going to be the difference. It's going to be the absolute value of the difference between your value and the true value. Okay, so just keep in mind too that I want you to actually make a prediction. And if there is a situation, which I don't believe I haven't ever seen this happen, but if there were to be a situation where a student had 0 as the deviation for each of the values they predicted, then you will get a 0 on this portion of the lab. So just keep that in mind also. Okay, the other thing I wanted to go over real quick is if we go down here to this part here, this is talking about group numbers and looking for the general number of electrons in the outer level. These are going to be your valence electrons, so keep that in mind. And if you think about AA, I want you to think about what would be generally true for AA. So the next thing is you're going to write the configuration, the general configuration for the valence electrons in each of those groups. So for example, if we look at group 1, we know that since it's in the S block, in the first column of the S block, that the valence electrons would all be S1. So we're not including here the period number or the energy level number. We're just looking at the valence electrons. Remember, you're looking at S and P. For the oxidation states, you can use your charges that we've been using. And you don't have to, I know earlier in the lab, what you will see, let me pull this back up, is you'll see that they have a very complex way of making predictions about charges. Don't worry about using these rules here. For this, I just want you to look at the general charges for your group. So if you look at, for example, group 1, we know that, for example, lithium, all those elements have a +1 charge. And then for symbol for one element which fits this description, I want you to look at what you've written down and make sure the element that you write down fits that description. So in this case, that could be really any element for group 1. So I'm just going to put down lithium since that's what we were talking about. So that's how you do this. The very last thing in the lab I want to go over is for here, make sure you are examining what you actually have on your graph. Okay, so look at your graph, see what the general trend is in each period, each group, and then which group from your graph has the largest radius for a given period, and which one has the smallest radius. So this will be from your graph. Okay, so if you have any questions about the last parts of the lab, please feel free to email me. So good luck on this.